The support for thread may be provided either at user level for user thread or by the kernel for kernel thread. User thread means thread management is done by user-level thread libraries. Kernel thread are supported and managed by the kernel. The user thread are managed in the user space. Each process needs its own private thread control block to maintain and keep track of the thread in that process. Now, for example, we have the user space and the kernel space. In the user space, we have two processes, process 1 and the process 2. In the process 1, we have 2 threads. In the process 2, we have 3 threads. And these threads are all implemented as user threads. Now the process itself will maintain this thread. The process 1 will maintain and keep track of 2 threads, and the process 2 will maintain and keep track of these 3 threads. The user process itself maintain and manage these threads. And kernel knows nothing about these 5 threads, 2 threads in process A1 and 3 threads in process 2. The kernel manages the ordinary single thread process. It will maintain the process control block of process 1 and the process control block of process 2. The thread don't need any assistance from kernel. And the switch between threads is fast because the user process create and switch this thread. No need to go to the kernel. No need to evoke the kernel. Now, the original Unix, the operating system, they don't support the thread. So if the user want to create the multiple thread, they need to implement user thread. The kernel thread are supported and managed directly by the kernel. All the thread control blocks are managed or maintained by the kernel. The kernel also maintains a traditional process control block to keep track of processes. Now, for example, we have the process 1 has 2 processes, has 2 threads, and the process 2 has 3 threads. And now the kernel will maintain this 2 process control block and will also maintain this 5 threads. 5 threads and 2 threads belong to process 1 and 3 threads belong to process 2. This in the kernel space, user space. The creation, destroy, and scheduling of threads are executed by system calls. System calls are part of kernel. So the kernel will create, destroy, and schedule the thread. The switch between threads is costly because this process needs to evoke kernel to switch between threads. And now the Linux, Windows, and the Mac OS all support kernel threads. We have user threads and kernel threads. A relationship must exist between user thread and the kernel thread. Now we look at 3 common ways of establishing such a relationship. We have the many-to-one model, one-to-one model, and the many-to-many model. First one is the many-to-one model. This means that many user level threads are mapped to a single kernel thread. The thread management is done by the thread libraries in user space, so it is efficient because thread management the thread management doesn't invoke kernel. But the disadvantage of many-to-one model is one thread blocking causes the entire process to be blocked. Also, the multiple threads are not able to run in parallel on multi-core architecture or the multiprocessor architecture, because in kernel, there's only one thread. So now the almost no operating system currently use many-to-one model. Next one is a one-to-one model. In one-to-one model, each user level thread is mapped to a kernel thread. Create a user level thread means to create a kernel thread. Now the one-to-one model is more concurrency than many-to-one model. Here the number of threads per process sometimes is restricted due to the overhead. If the user creates too many threads, that means the kernel needs to create the corresponding kernel thread. It may cause the overhead. So we will limit the number of threads created by each process. And now the Windows, Unix, Linux all use one-to-one model. The user creates a user thread, and there is a corresponding kernel thread to this user process, to this user thread. The last one is a many-to-many model. This means that many user threads are mapped to many kernel threads. The operating system or the kernel can create a sufficient number of kernel threads. But normally, this model multiplexes many user threads to a smaller or equal number of kernel threads. This model, the many-to-many model, is more flexible than many-to-one or one-to-one model. But in practice, it is difficult to implement many-to-many model. So now this many-to-many model is not very common in the operating system.